Okay, hello everyone. In a new video. In this one we are going to solve quiz number 3 of chapter 3, which is the chapter of DC voltage. Then here the remarks are given by this quiz consists of one obligatory exercise in one page. Answers must be included on the provided answer sheet. So this is it, exercise number 1. The title of this exercise is circuit analysis. So one must always keep an eye on the duration of this quiz, which is given by 15 minutes. Okay, so probably it will take me a bit longer than 15 minutes because I need to explain everything. Then let's start directly. So exercise 1, document 1, they mentioned the document, now we can use it. Shows an electric circuit that consists of a DC voltage source of voltage UPN is equal to 12 volts. Then the trick in solving such type of exercises is to write the applied voltage on the electric circuit itself. So here we have that UPN is equal to 12 volts. 12 volts. A voltmeter and an ammeter. Connected to this source we have 4 lamps given by L1, L2, L3 and L4. So these are the lamps. So L1 and L2 are connected in series, whereas L3 and L4 are connected in parallel. K is a closed switch. I is the main current, so this is I. I3 and I4 are the currents traversing the lamps L3 and L4 respectively. The given ammeter is of negligible resistance. So here they are telling me given UAB is equal to 3 volts, so this is 3 volts. UCD is equal to 2 volts and I is equal to 0.5 amperes and I4 is equal to 0.1 amperes. As I have mentioned, it's important that we label the applied voltage and the traverse current. Now in number 1, they are telling me that UPA is equal to 0. Justify. Notice that across P and A we have a connecting wire. Then let's say the voltage across a connecting wire is 0. Then in this case UPA is equal to 0. So notice that all quantities in physics must have a unit, but here because it is 0, anything multiplied by 0 is 0, so no need to label the volts. Okay, now in number 2 they are telling me UEN is equal to 0. Justify. So across E and N we have a closed switch, so let's say the voltage across a closed switch is 0. Because it acts as a connecting wire. So in this case we have that UEN is equal to 0. Now in number 3 they are telling me the voltage across the ammeter is 0, which is given by UDE. Across the terminals D and D we have an ammeter. Justify. We know that always the voltage across an ammeter is 0 because it is of negligible resistance. So the voltage across an ammeter is 0 because it is of negligible resistance. So in this case we have that UDE is equal to 0. So before we proceed to part 4, since in parts 1, 2 and 3 they ask me about the voltages across different branches, then we expect that they will ask me about the law of addition of voltages. Then indeed in part 4 they are telling me to determine the voltage UBC across the lamp L2. So we are interested in determining this voltage. Knowing that we know the voltage across the battery, the voltage across the lamp L1 and the voltage UCD, then all of these are related by the law of addition of voltages. So let me make some space here. And let me say for part 4 as a title, apply law of addition of voltages. Then how do we apply this law? Always on the left we write the voltage of the battery, which is given by UPN. And on the other side of this equation, we'll go from the point P to the point N across different electric components, making sure that UBC must appear in the equation because we are requested to determine the voltage UBC. So from P, we will go to the point A. Now from A, we'll go to the point B. From B, we will go to the point C, and from C to D. And from D to E, and eventually from E back to N. So notice that this is a valid equation because on both sides we have started with P and ended with N, and each letter we have inserted twice, okay? So knowing that we are interested in determining the value of UBC, now UPN is equal to 12 given, UPA is equal to 0 justified, UAB is equal to 3 plus UBC. Now UCD is equal to 2. Now UDE is equal to 0 justified, and UEN is equal to 0 justified. So in this case we have that 12 is equal to 5 plus UBC. Now what's the type of this equation? This is a linear equation and one unknown. The unknown is UBC. How to solve this equation? We put UBC on one side and all the other numbers on the other side. Then in this case UBC is given by 12 minus 5, which is equal to 7. Since both 12 and 5 are expressed in volts, so the value of UBC will be expressed in volts. So UBC is equal to 7 volts. And this is given by 7 volts. Now in part 5 they are telling me specify the voltage measured by the voltmeter, and here by specify it means that we need to indicate with the justification. Notice that the voltmeter is connected in parallel across the lamp L1, so it is measuring the voltage of the lamp L1, which is given by the applied voltage 3 volts. But notice that in this case the voltmeter, it will measure 3 volts plus 3 volts or minus 3 volts, and this depends on the COM terminal. So notice that if the COM terminal is connected back to the negative pole, so this is negative and this is positive. Since the COM terminal is connected to the negative pole, then the voltmeter will measure a positive reading. So let's say since the COM terminal is connected to the negative pole, then the voltmeter will measure or will indicate positive reading. So it will measure a positive reading which is given by plus, but this is not enough. We need to indicate the value which is given by 3 volts. So this is the reading of the voltmeter. Now in number 6 they are telling me the lamps L3 and L4 have the same voltage. Why? Here they are asking for justification and not for calculation. So notice that the lamps L3 and L4 have two terminals in common, and they are given by the terminals C and D. So let's say that they are first connected in parallel. So as a title we need to mention the grouping. So L3 and L4 are in parallel, and we know that according to law of uniqueness of voltages they have the same voltage. According to law of uniqueness they have the same voltage. So in this case the voltage of the lamp L3 is equal to the voltage of the lamp L4, which is denoted by UCD and which is given by 2 volts. So why do we refer to the voltage of the lamp L3 and to the voltage of the lamp L4? Just to distinguish between them. And in this case, they are equal to the applied voltage UCD because they are connected in parallel, okay? So this is also equal to the voltage UCD. Now we have reached part 7. They are telling me calculate the electric current I3 traversing the lamp L3. We are interested in determining I3. So notice that at the point C, the main current, which is given by I, splits into two currents, and they are given by I3 and I4. So we can say that I is equal to I3 plus I4. Always in physics, we need to mention the law that we are using. Here, because we are adding currents, we have used the law of addition of currents. So apply law of addition of currents. Knowing that we are interested in determining the value of I3, so the value of I is given by 0.5, we keep I3 as an unknown, and the value of I4 is given by 0.1. Now what's the type of this equation? This is a linear equation and one unknown. The unknown is given by I3. How do you solve this equation? We put I3 on one side and all the other numbers on the other side. Then I3 is given by 0.5 minus 0.1, which is equal to 0.4. Since both 0.5 and 0.1 are expressed in amperes, so the value of I3 will be expressed in amperes. Then I3 is equal to 0.4 amperes. And now let me label this current on the electric circuit here. Finally, in part 8 of this exercise, they are telling me to indicate the current measured by the ammeter. So first we need to determine which current is the ammeter measuring. So here we have three currents, I, I3 and I4. So across the terminals of the lamp L3 we have the current I3. And across the terminals of the lamp L4 we have the current I4. So notice that at the point D, the currents I3 and I4, after they have split it from the point C, they join back at the point D to give me the main current I. So here the ammeter is measuring the main current I, which is given by 0.5 amperes. So in this case, the ammeter will measure either plus 0.5 amperes or minus 0.5 amperes, and this depends on the COM terminal as well. Notice that the COM terminal is connected back to the positive pole, so this is positive. And this is negative, so the COM terminal is connected to the positive pole. So let me say, since the COM terminal is connected to the positive pole, so it's always the opposite. Since it's connected to the positive pole, then the ammeter will indicate negative reading. So now we know that the reading is negative, so it is a minus. What about the value? We have mentioned that the value is given by 0.5 amperes. And here recall that indicate, it means that we need to specify with the justification. This is the justification, okay? So always the sign is not enough. We need to mention also the value that the ammeter is reading. And by this we are done with this exercise. So that's it for me in this video, guys. See you soon in another one.